Hey guys, welcome back. So today I'm going to show you guys some more of how we're going to do the manufacturing. So I'd mentioned I use Fusion 360. Oh, little thing popped away. So in here, this is Fusion 360. When I go here, you'll see we have options. We can design, we can do manufacture. We're going back and forth between these two. So we'll come up with a good design and then we'll figure out how to manufacture it. So let me show you what that looks like. Oh my God, why is this thing doing that? All right, I guess when it goes slow, it doesn't like it. I always do that quick and I don't. Anyway, so this is what we ended up with. I'll show you. So it starts off, ignore some of that junk up there. So you see op 1, that's where our new stuff starts. We got 2, 3, 4, and then it goes all the way down to the very last one is 13. We did all kinds of stuff here that's new and better that I've never done before. So one of the big ones is, let me show you. I'm gonna go to op 1 and I'm gonna click it. And what you're going to see is there's a big round piece of metal. This is what we purchase. This is the metal as it comes. It's just a big round disc. It's like 5 inches in diameter and it's about 1.25 inches thick, roughly. Those are approximate numbers. So what you'll note is when I go to operation 2, look at this now. See how it still shows that round piece of metal, but now it's got a rectangle cut in it? What we did, I've never done this in Fusion, but what we did was we made it carry. When we go to op 2, it remembers, it starts with whatever was in op 1 and it sees that we cut some metal away and it uses that as the setup for op 2. And as you work your way down, when you get to op 3, it uses whatever has been accomplished for the operations above it and so forth. So by the time I get to the end, this is what I'm actually going to end up with. Now this might seem intuitive, you know, people are watching this video going, well duh, of course you do it that way, but I've never done it this way. What I've always done is I would just have different setups, all based off of the same stock, or I would have different parts. Crazy stuff. And this is the first time I've ever done it this way. And this may not seem, I don't know how to stress how important this is. This is extremely important. And if you've never done this, or you don't make parts, it may not even seem obvious, like why this would matter. But what this means is that when I get down here to this last op, and you see what this part looks like, this is what it's actually going to look like. It's not assuming anything. This is, you know, if this is true, then this is what you'll end up with. That's why that's pretty cool. So I'll show you. Anyway, here's our first operation. So we take that round piece of metal, and you can see all these blue lines. It just goes around and cuts a lot of that off, and you end up with this. Since, I don't know if I've ever shown this on video, but so this software can actually do simulations. Now, I don't know why the stock shows up as a square here. This software is just goofy sometimes, but I promise you it's actually a round piece of metal. But this is what it's going to do essentially on the machine. Little cutter is going to go around and follow its toolpath, and as you can see, it's cutting that rectangle. There we go. And I'll show you some of the detail that went into this that's may not be obvious now, but you ever heard that phrase, pay now or pay later? That's kind of how this stuff goes. The better of a job you do up front, the better your parts will be in the end. So you see this little radius? It's kind of hard to get to show up. You can see that's kind of curved. That's because our tool has a radius on it. This is the first time I've ever modeled that in software, put a radius on a tool, because either I don't use those tools, or if I do use them, I just ignore it. But that actually matters, and I've paid for this so many times in the past where something that I modeled, and then I went and machined it and it didn't turn out right because that radius somehow screwed me up. So this time we put it in there, and sure enough, I've bumped into this issue several times trying to operations that look like they worked now don't work, and I'd have to go back and modify so you cut that metal off that the radius left behind. Again, there's like 1,000 little things that'll get you on this. So keep that in mind, guys. I'm not really an expert at this. I'm kind of stumbling my way. You know, I do have some experience, but I am stumbling my way through some of this. It's a lot to take in. Not to mention the fact that, you know, I designed all this and I got to make it work on my machine. But yeah, we went through this step by step. So like here's our second op. You can see everything's flipped. Now we're grabbing it in that rectangle. So basically, here's the bottom of the part. You can see that flange we just cut on there. That gets clamped down in a vise. And now you just got like this round piece of metal poking up. And then essentially it just goes around in a circle and machines that whole face down to some level. Then the next operation, still clamped in the vise, it goes around and cuts this profile. And you can see here it's actually doing that in 3 stages. This was 4 stages for so long. It took a ton of optimization to figure out a way to get that to be done in 3 instead of 4. But hey, doing it in 3 instead of 4 makes it faster. And that's why we did it. but a lot of work. It's crazy. You just see this and you're like, oh yeah, whatever. But man, hours and hours, guys. Then we do a facing op. This makes we bring this surface down to final size. So basically before, when we did our roughing, we got it pretty close, but we didn't get it all the way. And when we do the facing, that takes that last little skim coat off and gets it down to size. Then we've got some drilling operations. So you can see, you notice we keep changing this. You keep noticing this little thing. That's your datum, your XYZ. That's what's considered 0. I'll have a whole other discussion about that in a little bit. But you'll note every time I keep changing setups, you'll see that move. So in this operation, you can see some drill hole. We're just popping a hole there and there. And if you see, it doesn't even go all the way through. We're using a shorter drill bit. Then our next operation, we come back and finish drilling it. And you'll note, this drill doesn't start at the top, it starts down here. And if you look at our previous one, it's kind of hard to go back and forth. But you'll note when I do this one, see how it overlaps? So it starts drilling above the floor of the previous one. That way the bit doesn't crash into the bottom of the hole. But that way we also don't drill a bunch of air that doesn't exist, so this saves time. So yeah, just little things like that. I've never done this before where I got a drill bit to do a drill bit change and then jump in like that. So it's cool doing stuff like that, just speeds it up. Anyway, after that, got another change. Here's our part again. Now we're clamped up back on our flange, and we're going to do a contour. And what this does is it brings these surfaces down. It doesn't get them all the way to size. Actually, I better go check. Maybe it does. But it's that should get us really close. I got to go back and look at that. And after that's done, we got one more that comes through here, and this is what puts the final dimension on the outside. And this is one that kicked my butt. The solution was simple, but I didn't know how to do it, and I fought this for a long time. But you'll note, if you look at these little blue lines, you'll see like, oh man, I need a pointer. Basically, you'll see blue lines like here, and they kind of follow up and over and blah, blah, blah. But what you note is they're not here, and they're not here. We're leaving that material on the part. We're going to go back and face that off towards the very end. Remember those last two steps? We cut our registers, and then we cut that face. So we're leaving that material on there now so that it's still there when we want to do that cut. So after this, we do another, again, another flip. Now we're in the vise this way. And you can see we're doing some roughing. This is taking off a lot of metal as well. So we're getting actually deleting that flange. So we machined that flange on there earlier. Now we're machining it off. That's what this operation is. So that puts us to our next operation. This is op 9. This is a facing operation. So that's putting a finished face on that. Then we've got operation 10. This is a big one. So this is what is called a bore. So we already drilled these holes. You would think like, okay, cool, you drilled your holes, you're done, right? Well, no. So one of the issues you run into on a CNC machine when you start drilling holes that are deep is your drill bit can walk on you. So essentially you're trying to drill the hole. Let me kind of give you an idea. Say this is it, and this is your drill bit. And what happens is while you're drilling, your bit starts to do that, and it walks and ends up going crooked, or it goes that way, or it comes this way. It doesn't actually follow the center line of the hole exactly how you want. And that's just because drill bits are not like perfectly rigid, just the way they're designed. Especially if they start to get dull, they can do all kinds of weird stuff. So it's like what you could do is you could try to like always have a new drill bit or always have a really sharp one or try to program it perfectly, or I don't know. You could try to manage it. Or what I did instead, I said, you know what? Let it drill the hole a little crooked. A little bit. So if I need this hole to be, say, within, I don't know, 5 thousandths, you know, a brand new drill bit would probably do that. But maybe over time it wouldn't. But you know what's easier is to just say, you know what, drill it undersized. Let that drill bit walk 10 thousandths or whatever. It won't matter. Not actually 10. That'd be bad. But it can drift a few thou. And that's okay because what you do is we do this thing called a helical bore. So what this does, see this end mill? I kind of zoom way out. See how ridiculously long this tool is? This is one of those extended ridiculous length tools that is expensive. Well, that's what this does. This allows us to go in here and use a mill and circularly go around and machine that part. I'll actually run this real quick. You can kind of see what I'm talking about. So you can see, yeah, the stock's a little screwed up, so it doesn't look quite right. But, see how this is doing? Yeah, hold on, let me try to bring it back a little. So what it's doing is it's just going around in a circle. take that out. Let's see. Yeah, you can kind of see there. It's basically just interpolating itself in through a hole, and that's what's setting the bore. Pretty cool little feature. Anyway, what that does, that should get our hole probably within 1 to 2 thou. We should have a circle that's not only the right size, but also positionally in the right location. And this is important for, like, say a customer you're installing. Typically anybody that buys this cap is going to be running aftermarket ARP studs, which, by the way, since these caps are so big, the aftermarket studs, the typical ones don't fit, but no worry, I've already contacted ARP and I've got part numbers for ARP studs that do fit. So anyway, when you're installing your studs, you screw those in the block first. If these holes were a little crooked, then when you go to put your caps on, they might rub, or you might have to hit them with a hammer to get them to slide down the studs. And we don't want any of that. So we're trying to get these holes perfectly straight. You know, I'd rather this be a little higher quality than necessary than be a little short on quality. So by doing it this way with the carbide, even if our drill bits drill a little crooked, it won't matter, because when we come in and do that op, it'll fix it. So that's cool. You know, the downside is it takes 3 ops to put that hole in there, but the upside is this should be very consistent. I should be able to make 100 of these caps, and every one will have the holes in the right location with high accuracy. So here's our next operation. We got another one of these crazy tools. This is going to be this could be one of the hardest operations to do. Look what this looks like. If you zoom out, you can see our tool we got is absolutely ridiculous length to diameter ratio. This thing's poking out about 15 times or 20 times its diameter. So that's kind of a flimsy tool, hard to use, and we're cutting 4140, so I mean it sucks all the way around. And we're doing slotting, which is about the worst thing you can do. We don't know if this part's going to work, but this is what we're doing. And you can see here we got a bunch of little tiny passes. You can see each one steps down a little bit at a time, and we're hoping, you know, we've never done this. We definitely got to test this out, but we're hoping that works. And you can see we got to get the part clamped all crooked so that the end mill comes down straight. And what's funny is I did not realize how hard this tang was going to be to machine, because if you buy a traditional end mill and you try to make this, what happens is your tool just runs into the part, which is, you know, basically worthless. Yeah, I don't know why the simulation's all screwed up right now. Oh well, I'd show you that, but I probably need to restart Fusion. It's one of those softwares where you got to reboot it sometimes. But anyway, we got that sucker in there. It cuts our tang. Let's see. Next, we're down to the last 2 operations. This is, let's see. There we go. So our part goes in the vise like this. And you can see we just got 2 ops. We go on this side and we go on that side. And that sets our final distance on the flats. And if you look in the tool holder, you'll note how stubby that tool is. That's for rigidity, like we had talked about. And then after that, we do a facing op. There it is, big indexable, just flies across the face, faces that off to its final distance. And that's a part. Now, like I said, I know I still got missing a couple things. You'll note here, this has a sharp corner. I think we're going to throw a chamfer on that for the final product. So I have to, you know, I have to deal with that. That'll be fun. Maybe another op, I don't know, we'll see. But I'm probably going to throw a chamfer on that. I think that's a good idea. But yeah, this is what we've been working on. Like I said, a lot of time and effort went into this. This stuff is not easy. It certainly isn't easy for me. I'll tell you what, to me, this is like micro manufacturing, trying to be able to do this kind of stuff independently. And man, it's tough. A lot of work goes into this. But if y'all ever want to get into this stuff, you know, don't be afraid to jump in and try it. But yeah, there's a learning curve. Although I can say, if you're going to do this Fusion 360 program is pretty sweet. Being able to jump back and forth from a design to cam and really kind of speeds things up. So yeah, I guess I'm going to jump into another part of the video and show y'all that.